Let's move to the next question. In this question, we are given a figure. In the adjoining figure, we have ABCD and it is a cyclic quadrilateral with opposite sides AD and BC. And these two sides are produced and they met at a point E. And we are given the adjacent angles, that is DAB is 30 degrees and angle ABC is 110 degrees, and we are supposed to find angle DEC. So let's work out the problem. Here we take ABCD is a cyclic quadrilateral and the opposite sides are produced to meet at angle E. And here we form a triangle DEC. Using this we find these angles. To find this angle we need to find the remaining angles of this triangle. So how we can find it means, so by finding these angles, that is adjacent angles, angle D and angle C, we find the angle E. So let's start step by step process. We are given the adjacent angles, angle A. To this angle A, angle C is opposite. And we are given angle B, that is angle ABC. To this angle B, angle ADC is opposite. So using these two, we find the remaining angles. What is the relation between these two means? In a cyclic quadrilateral, sum of opposite angles is 180 degrees because opposite angles are supplementary. Now we take angle DAB. To this angle, we have angle DCB is opposite. So their sum must be 180 degrees. And angle DCB is equal to 180 minus angle DAB, and it is 30 degrees. So 180 minus 30 is 110 degrees. So we have angle DCB which is 110 degrees. Similarly, we have angle ABC. To this angle ABC, we have angle ADC which is opposite to it. And their sum must be 180 degrees. And angle ADC is equal to 180 minus angle ABC, which is 110 degrees, and it is equal to 70 degrees. Thus we get the angles. Using these angles, we have to find the remaining angles of triangle DEC. And here we have triangle DEC. In this triangle, DE is side, and we have ADE is a straight line. So angle ADC and angle CDE is a linear pair. That is, their sum must be 180 degrees. We already know angle ADC, which is 70 degrees, and we calculate angle CDE, and it is equal to 180 minus 70, which is 110 degrees. Similarly, we have another straight line, that is DCB. So DCB is a straight line. We have angle BCD and angle DCE, and their sum must be 180 degrees. It is because it is also a linear pair. So angle DCE is equal to 180 minus angle BCD, which is 150 degrees, and it is equal to 30 degrees. Therefore, we know two sides of triangle DEC, that is 110 and 30 degrees. So the remaining angle is 180 minus the sum of remaining angles. Therefore, in triangle ADE, angle at A plus angle at D plus angle at C is equal to 180 degrees. We have to find angle DEC. Here we have to find angle DEC. It is equal to 180 minus sum of the remaining angles, that is 110 minus, that is 110 plus 30. It is equal to 180 minus 140. It is 40 degrees. Therefore, angle DAC is 40 degrees. And this completes our solution. Let's move to the next question. In this question, Sumit has built a cubical water tank with lid for his house with each outer pair edge, that is 1.5 meters long. He gets the outer surface of the tank excluding the base covered with square tile of side 25 centimeters and we have to find how much he would spend for the tiles. If the cost of tiles is 360 rupees per dozen. So let's work out the problem. Here we are given a cubical tank whose edge is 1.5 meter long. Let us suppose this is a cubical tank and its edge is 1.5 meter long. Coming to next, Sumit had planned to cover the entire tank excluding the base to its outer surface with a square tiles, and the dimension of square tiles is 25 centimeters. So side of square tile is 25 centimeters, that is 0.25 meters. It is because we are given this dimension in meters, so we convert it into meters. Let's find out the area of this cube. Note that we have to find the area of cube in such a way that we have to exclude this base, because he is not covering the base with square tiles. We have to find the area of 5 surfaces. Area of face is a square and we have 5 such faces, so 5 times a square, and it is equal to 5 times 1.5 times 1.5 meter square. Similarly, area of square tile and its side is 0.25 meters, so 0.25 times 0.25. It is the area of one square tile, and we don't know how much tiles are needed to cover this surface. So we assume n is the number of tiles that are needed to cover the outer 5 surfaces. Then the area of 5 faces must be equal to n times the area of each tile, because we are covering the entire 5 outer faces. Now substitute their values, that is area of 5 outer faces is 5 times 1.5 times 1.5 and n times 0.25 times 0.25. By transposing this, we get n is equal to 5 times 1.5 times 1.5 divided by square of 0.25, and it is equal to 180. So the number of tiles needed to cover the 5 outer faces is 180. If we go through the problem, we are given the cost of tiles, that is per dozen we needed 360 rupees. That is the cost of 12 tiles is 360 rupees. That means the cost of one tile is 360 upon 12 and it is equal to 30 rupees. We need 180 tiles. So the cost of 180 tiles, that is the cost to be spent, is n times rupees 30. Since for each tile we are paying 30 rupees and the total cost is 180 times 30 rupees, and it is equal to 5,400 rupees. And this completes our solution. Let's move to the next question. In this question, we have to draw the graph of the linear equation 4x plus y is equal to 6. And we have to find out at what points the graph of the equation cuts x-axis and y-axis. So first, to plot a graph of the equation 4x plus y is 6, we need to find at least 2 solutions so that we can draw a straight line. To find 2 solutions, we assume the value of x. First we take the value of x is 0 and then find its corresponding value. For x0, we have 4 times 0 plus y is 6. That implies the value of y is 6. Similarly, to find the next solution, we take the value of x is 1 and then find its corresponding value. Here we have 4 times 1 plus y is 6. That implies y is 6 minus 4. By transposing 4, we have 6 minus 4 and it is equal to 2. Therefore, we get 0, 2 is one solution and 1, 2 as another solution. So we take these points on the graph and draw a straight line. Let's look at the point 0, 6. Here the x coordinate is 0. That means the distance of this point from y-axis is 0. So 0, 6 lies on y-axis. It is here. Similarly, we have to plot 1, 2. Here the x coordinate is 1. So the distance of this point from y-axis is 1. It is somewhere here. So we take here as distance 1. Since the y coordinate is 2, the distance of this point from x-axis is 2. Here is the point 1, 2. So now we draw a straight line passing these 2 points. And here we get the graph of the equation 4x plus y is equal to 6. Now it cuts the y-axis at the point 0, 6. Similarly, to find the point on y-axis, we move to the x-axis. Here we have the graph cuts in between 1 and 2. If you look at the graph carefully, we get it is exactly in between 1 and 2. So it is 1.5 units away from origin. Therefore, it cuts x-axis at 1.5, 0 and y-axis at 0, 6. And this completes our solution. Let's move to the next question. In this question, a student open his book and note down the unit digit of the right hand page. He repeats the process for 150 times. The outcomes are tabulated here. Based on this information, we have to say the probability of occurrence of 1 or 4 has the unit digits. Similarly, we have to find the probability that at least 5 has the unit digits. So let's work out the problem. In this experiment, student opened his books 150 times. Here he is given that he repeats the process for 150 times. Therefore, the number of trails, that is the total number of outcomes, are 150. Now we have to take the probability that 1 or 4 has the unit digits. So we denote E is the event which represent 1 or 4 has the unit digit. Now number of favorable outcomes to have 1 has our unit digit is 25. In this event we have 4 also. So the number of favorable outcomes for 4 to have our unit digit is 10. Therefore, the sum of these two numbers, 25 and 10, gives the number of outcomes favorable to event E. And we already defined probability is the ratio of number of favorable cases to a particular event to the total number of outcomes. Here 35 are the favorable outcomes to event E and we have 150 as our outcomes. Here 5 is a common factor. On dividing with 5 we get 7 upon 30. This is the probability to have 1 or 4 as unit digit. Now we move for next question. Now we denote F is the event which represent that the unit digit has at least 5. According to it, we have to find the number of times the unit digit has occurred at least 5, and it is equal to sum of 4, 11, 20, 15 and 12, and the sum is 62. Therefore, according to the definition of probability that the occurrence of at least 5 has unit digit is the total number of favorable cases to event F, which is 62, to the total number of trails, that is 150. Here 2 is a common factor. Then we have the probability has 31 upon 75. This is the probability of occurrence of at least 5 has our unit digits. Let's move to the next question. In this question, P is any point on the median AD of triangle ABC. We have to show that area of triangle APB is equal to area of triangle ACB. Let's work out the problem. Let ABC be the triangle, and here we are given median AD. What is median? A median is a line segment joining a vertex to the midpoint of opposite side. Here D be the midpoint of side BC, then AD becomes our median. If you look at the figure, we form two triangles, triangle ABD and triangle ADC. From the properties of median, median divides a triangle into two smaller triangles in such a way that the area of these two triangles is equal. Therefore, area of triangle ABD is equal to area of triangle ADC. Similarly, we are given a point P on median. So we suppose this is the point P and we join the vertex B and C to P. Now we got a triangle BPC. In this triangle BPC, PD is median. As we consider above, the median PD divides the triangle into two triangles of equal area. Therefore, area of triangle PBD is equal to area of triangle PDC. Now we got two equations, equation 1 and equation 2. Now we got two equations, equation 1 and equation 2. Let's subtract equation 2 from 1. That implies area of triangle ABD minus area of triangle BPD is equal to area of triangle ADC minus area of triangle PDC. Here what we get? When we subtract area of this triangle ABD from PBD, then we get the area of triangle ABP. From the above condition, it is equal to area of the triangle ADC minus area of triangle PDC. It is equal to triangle ABC. It is equal to area of triangle APC. Therefore, we get the condition area of triangle APB is equal to area of triangle ACP. And this completes our solution. Let's move to the next question. In this question, mean age of 20 students is 15 years. If the age of teacher is included, then the mean age becomes 17 years. We have to find out the age of teacher. Let's work out the problem. According to the problem, we are given mean age of 20 students. It is equal to 15 years. Here, mean is the ratio of total age of 20 students to the total number of observations, which is 20. It is equal to 15 years. So we have total age of 20 students is 15 times 20, which is equal to 300 years. Now we are given if teacher age is included, then the mean age becomes 17 years. We don't know teacher age, so we assume X is the age of teacher. According to the problem, we have new mean is 17 years. Now, new mean is the ratio of total age of all students including teacher, that is X plus 300. And then we have 21 has total number of observations. It is equal to 17. Then by simplifying we get X plus 30. Then by simplifying we get X plus 300 is 17 times 21, which is equal to 357. Therefore, the value of X is 357 minus 300, which is equal to 57 years. Therefore, we get the value of X is 57 years and the age of teacher is 57 years. Let's move to the next question. In this question, we are given the values of X and Y and they are thought to satisfy a linear equation. From this point, we have to draw the graph and then we have to state at what point it cuts the x-axis and y-axis. So let's work out the problem. From the given table, we form ordered pairs x comma y, which is 1 comma 1 and 2 comma 3. Here we denote P is the point 1, 1, and Q is the point with coordinates 2, 3. So let's plot these points P and Q on the graph. The x coordinate is 1, so the distance of P from y axis is 1. This is the point, and to plot y coordinate we move along the positive y axis, and it is y coordinate is also 1, so the distance of point P from x axis is 1. Therefore this is our point 1, 1, and we mark it as point P. Similarly, here we have Q point which is 2, 3, and x coordinate is 2. Therefore the distance of point Q from y axis is 2. And then to plot y coordinate we move vertically, that is in the positive direction of y axis, and here y coordinate is 3. Therefore the distance of Q from x axis is 3. Here we have the point 2, 3. After joining these 2 points we will get a straight line. Let's join these 2 points P and Q. After joining the points P and Q we get a straight line, and this is the graph of these points. And here the straight line cuts the x axis at this point. Let this point be A. Similarly it cuts the y axis, and this point be B. And here we have to find the coordinates of A and B, because we have asked to find the point at which the graph cuts the x axis and y axis. So let's find the coordinates of point B. And here the coordinate B lies on y axis, so its distance from y axis is 0. Therefore its x coordinate is 0. And here the distance of this point from x axis is 1 unit, and it is along negative y direction. So its y coordinates becomes negative y. Similarly, the coordinates of point A is, here the point A lies in between origin, that is 0 and 1. If we take the graph in millimeters, we get this value, it is exactly half. So it is 0.5 or 1/2. Since the point lies on x axis, its distance from x axis is 0, therefore its y coordinate is 0. Therefore the coordinates of points are 1, 2, which cuts x axis, and 0, -1, at which the point cuts y axis. Therefore the graph cuts the x axis at point A, and its coordinates are 1/2, 0. Similarly it cuts the y axis at point B, whose coordinates are 0, -1. And this completes our solution. Let's move to the next question. Here we are given, if the diagonals of a parallelogram are equal, then we have to show that it is a rectangle. To solve these kinds of problem, we should apply a definite pattern. Here we write the given statement, and then our aim to prove what is we have to prove, and then we prove according to necessary conditions and by applying geometry. So first we take ABCD is a parallelogram, and it is given that the diagonals are equal. Therefore the diagonals AC and BD are equal, and we have to prove ABCD is a rectangle. And we prove, if we look at the figure, how we can prove this it is a rectangle? If this angle BAD and angle ABC are right angles, then we say that ABCD is a rectangle. So we have to prove this, these are right angles when the diagonals are equal. So we consider two triangles, that is triangle ABC and triangle BAD. In these triangles, opposite pair of sides are equal, because in a parallelogram opposite pair of sides are equal. So in these two triangles, side AB is equal to side DC and side AD is equal to side BC. And in the question we have given diagonals are equal, therefore AC is equal to BD. Here we have these two conditions. By side congruency, we say that triangle ABC is similar to triangle BAD. Therefore we have two triangles and they are similar. Now we get triangle ABC is similar to triangle BAD. So by congruent parts of congruent triangles, we have side AB, which is corresponding side, and to this we have corresponding side AC and BD, and their corresponding angles must be equal. So angle ABC is equal to angle BAD. From the properties of parallelogram, we know that sum of consecutive interior angles, that is angle BAD and angle ABC, is supplementary. Therefore, we have sum of angle ABC and angle BAD is 180 degrees. By substituting the values, we get the value of angle ABC is equal to 180 upon 2, which is 90 degrees. Therefore, we get a right angle triangle. And here, the angle BAD is a right angle which is 90 degrees. Similarly, angle ABC is also a right angle. If we consider the upper two triangles also, we will get similar result, that is both are right angles. So by redrawing this figure, we get a rectangle. Therefore, ABCD is a rectangle. And this completes our solution. Let's move to the next question. Here, if two circles are drawn taking two sides of triangle as diameter, we have to prove that the point of intersection of these circles lie on the third side. That means we are given a triangle. By taking any two sides, circles are drawn. Let this be a circle, and here the diameters of these circles are the sides, and we have to prove that the point of intersection of these two circles lie on the third side. So let's prove this. Here we have a triangle ABC and circles with diameter AC and BC. Let the point of intersection of these two circles be D, and when we join CD, we have to prove that D lies on AB. So here we note down the given data, and we have to prove that D lies on AB. Now consider the triangle with diameter BC. Here we note that we form a triangle BDC. In this triangle, it forms in semicircle of this circle. Therefore, angle of any triangle in semicircle is right angle. Therefore, angle BDC is equal to 90 degrees. Similarly, in this triangle with diameter AC, we have a triangle ADC. And here also, angle in semicircle is 90 degrees. So we have angle ADC, which is 90 degrees. So by using this, we prove the given problem. And we have two triangles ADC and BDC, and they are right angle triangle at D. Therefore, we have angles ADC is a right angle and BDC it is also right angle. It is because angle in semicircle is right angle. So by adding these two, we get angle ADC plus angle BDC. We get the sum as 180 degrees. Therefore, we can say that AB including D forms a straight line, because angle formed by a straight line is 180 degrees. And ADB is a straight line, so D lies on AB. And this completes our solution. Let's move to the next question. In this question, a heap of wheat is in the form of a cone, and we are given the diameter of base of heap, that is diameter of base circle of cone is 8 meters and its height is 3 meters. We have to find its volume, and also the heap is covered by a canvas to protect it from rain. So we have to find how much area of canvas which we needed to cover the cone. That means we have to find the surface area and volume of cone. So let's work out the problem. Here we take cone ABC. Let the center of base circle be O, and we are given diameter, that is 2 times radius of base circle, which is 8 meters, and radius is 4 meters, and the height of the cone, which is 3 meters. And we are asked to find volume and surface area. We know that volume of a cone is 1/3 pi r square h, where r is the radius of base circle and h is the height of cone, that is AO, and we are given AO is 3 centimeters. So let's substitute their values. We have 1/3, pi value is 22/7, and radius square, which is 4 times 4, and height is 3. So numerator 3 and denominator 3 are cancelled out. We remain with 22 times 16/7, and that is equal to 352/7. On converting it into mixed fraction, we have 50 and 2/7. It must be in meter cube. So let's find its surface area. And area of convex required is the surface area of cone. And remember, the surface area of cone is pi times RL, where L is the slant height. The slant height is AC. So let's determine the slant height. We know the height of cone, which is 3 meters, and base radius is 4 meters. And base radius is 4 meters. By applying Pythagoras law on triangle AOC, we get square of hypotenuse, which is L square, is equal to sum of the square of other two sides. Therefore L square is 25, and we get the value of L, which is 5 meters. Let's substitute. The value of pi is 22/7 and radius is 4, and the value of L is 5. We get 22 times 20/7, and it is equal to 440/7 meters square, since surface area units are meters square. And this completes our solution.